Hello and welcome to Master Academy. We are going to talk about sequence and series. So we'll do that by solving this question. But before we do so, let us look at the stuff that you need to know in order to understand and be able to solve this question. So there are different types of sequences out there, one of them being the arithmetic sequence. So how is arithmetic sequence different from other sequences? Well, I'm going to explain this using these three terms. Suppose now these are our terms, the first three terms of our sequence. And then normally we call these terms term number 1, number 2, number 3, and then this continues until we get to the last term. So I'm just going to call this one Tn, which is the last term. Now we say that the common difference or the difference between two consecutive terms must be the same in order for this to be considered an arithmetic sequence. So as you can see, I'm getting the difference between these consecutive terms. So what y minus x is that, z minus y is that, right? Now for this to be an arithmetic sequence, this needs to be the case. So y minus x must be the same as z minus y. And then if this is the case, if these two are equal, therefore we just call this one D. Then we call it D because it's a common difference. Common difference. All right. So now the formula that we use to calculate terms on an arithmetic sequence is this one. So this is the general formula. The general formula is used to calculate any term that is part of this sequence. So now let me explain to you as to what each of these letters really mean. So I'm going to start with A. A is also known as T1, which is term number 1. It is the first term. It is the first term of the sequence. Then the next one is D, of which I've already explained to you as to what exactly D is. This is the common difference. With the common difference, when you look at your sequence, if it happens that the difference between consecutive terms is not consistent, it's not the same, then we can't consider our sequence to be an arithmetic sequence. But if as soon as the constant difference is the same, meaning that this is equal to that, then we can say, okay, this is an arithmetic sequence, and then we have a common difference. N is the position of the term in the sequence. And then lastly, we have Tn, which is the nth term. An arithmetic series, it's perhaps you might have something like this, where you have T1 plus T2 plus T3 plus until you get to the last term. If we use the terms that we used in the arithmetic sequence, we would have something like this: x plus y plus z, and then this continues. So we're basically adding all of them. And then now the general formula that we use to calculate the sum of all these terms is this one. Sn is equals to n over 2, 2a plus n minus 1, in brackets D, and then we close the bracket. Now, this is the general formula. we can look at this. If we agree that, okay, if you and I agree that, okay, the last term, using this formula, we can find the last term. So the last term is going to be a plus n minus 1 d. If we can go onto this and then substitute where there's this, where we find this part, we just replace it by L. We replace it by L. So doing so, we can rearrange this to have something like this. So we can say Sn is equals to n over 2, and then we have a plus a. So instead of having 2a, we make it a plus a. And then this one is plus n minus 1 d. Now this part is what I'm looking for here. So it is exactly the same as this. So we can replace this by L, by that L. And then Sn is equals to n over 2 a plus L. And then this is another formula that we can use for the arithmetic series. So we can either use this one or that one. So these are the two formulas that we can use. Now we can go ahead and solve the question. Now the question reads as follows. It says the sum of an arithmetic series is 100 times the first term. So with a key point here, it's 100 times the first term, while the last term is 9 times the first term. Calculate the number of terms in the series. So we're looking for n. So right, it says now the arithmetic series, which is Sn, is 100 times the first term. First term is T1. But we know that, okay, T1 is equals to A. Therefore, Sn is going to be 100 times A, which is the same as just 100A. And then we also know that, okay, the last term, which is L, is 9 times the first term. So the last term, L, is equals to 9 times T1. If we already said that T1 is equals to A, we are going to replace this T1 here by A. And therefore this becomes 9 times A, which is the same as 9A. Now we have these two. We can name them 1 and 2 just like I did. And then now we go to the two formulas that we have. Out of these two formulas, we look on the data that we have. We do have A and we do have L. We are looking for N. We do have Sn. We don't have any of this. Maybe we should copy these formulas down so that it will make more sense. So we have Sn is equal to n over 2, 2a n minus 1. And then this one, Sn n over 2, a plus L. We have to choose between these two. Now, based on what we have, we do have Sn, that is, we do have L, we're looking for N, and when you check on this formula, we have this, which is this part here, and then we have L, A is A will never change, and then we have L, which is this part, is given to us. Therefore, we can use this formula here. We can't choose this one because we don't know what the common difference is. Using this one, Sn is equals to n over 2, a plus L, and then we substitute what we know. Sn is 100a, so 100a is equals to n over 2, a plus L, so we put 9a, and then this is equals to n over 2 times 10a, because a plus 9a gives us 10a. Therefore, from here, I can rearrange this to say, okay, my n is going to be 100a times 2 over 10a. So I only made and the subject of the formula. So cross multiplied and then divided by 10a both sides. So therefore, n is equals to 20. Because look at this, the a's will cancel out, and then 100 times 2 is 200, divide by 10, you get 20. So we have 20 terms in this series. Thank you so much for watching. I hope you learned something, and please, if you're new to the channel, please subscribe and let your friends know about this channel. Thank you so much. Goodbye.